So remember, if you have got n being equal to 1, let me start with 2. Okay, if you have got n being equal to 2, it means your L is going to be 0 and your L is also going to be what? 1. Now remember, let me actually start from n is equal to 1 so that we see how this comes about. If you have got n being equal to 1, meaning that your L is going to just be 0. Okay? When L is equal to 0, meaning that the orbital which you have is the s orbital. That is the s orbital. But because it is in the first energy level, this is going to be called the 1s orbital. Remember, the s orbital can only have two electrons, like it is coming from the L is equal to 0, it can only have two electrons. And then when you have got n being equal to 2, this means that you are going to have L being equal to what? 0 and L being equal to 1. And remember, when L is equal to 0, that is still an s orbital, but when L is equal to 1, that is a p orbital. But because this is coming from the second energy level, this is going to be called the 2s and the 2p. Okay? When your n, when you have got n and it is equal to 3, should know that L then is going to be equal to 0, 1, and 2. Okay, when L is equal to 1, 0, that is the s orbital. When L is 1, that is the p orbital. When L is 2, that is the a d orbital. But because they're coming from the third energy level, we're going to put a 3 in front. 3p, 3s, 3d. Okay, when L is equal to 4, meaning that you're going to have L, I mean when L is equal to 4, you're going to have L, just a minute please. Okay, so when L is equal to 4, now I want someone to tell me what will be, if n is equal to 4, what will be L? Yes? Musonda. Okay, it seems you people can't see what I'm writing. Alright, so did we get what is here? Have we understood how this is coming about? Have you, Martha, have you understood or not? Alright, so we are saying when n is equal to 4, I want someone to tell me what will be the values of L. What will be the values of L? Okay, so L is going to be 0, 1, 2, and 3. That's correct. So when L is 0, we know that is S. When L is 1, that is P. When L is 2, that is D. When L is 3, that is F. Because they're coming from the fourth energy level, we're going to be attaching a 4 in front. So that will be 4P, 4P, 4S, 4P, 4D, and 4F. Alright, now remember, whenever you see L is equal to 0, that is the s, and it can only have a maximum of 2 electrons. So all the s orbitals, it doesn't matter where they are, whether in the first energy level, second, and third, they can only have a maximum of 2 electrons. And then the p orbital, remember it comes from where? The p orbital comes from L is equal to 1. And when L is equal to 1, we know that ML is going to be negative 1, 0, and positive 1, right? So there are 3. So this means that there are 3 orbitals. Okay, whenever L is equal to 0, meaning that you have got 3. I mean, whenever L is equal to 1, meaning that you've got 3 orbitals. And each orbital can have a maximum of how many electrons? 2 electrons. So that means the p orbital can have a maximum of 6 electrons. And for the d, it comes from when L is equal to 2. And remember, ML is going to be from negative 2 to positive 2. Negative 2, negative 1, 0, 1, and 2. So how many are there here? There are 5. Okay, each orbital can have a maximum of 2 electrons. So 2 times 5, that is going to be 10. So that means each d orbital can have a maximum of 10 electrons. The F comes from when L is equal to 3. So ML is going to be from negative 3 to positive 3. That is going to give us 7. 7 times 2, 14, meaning that the F can have a maximum of 14 electrons. This explains why first energy level only 2 electrons, right? The second energy level has got S and P, meaning it has gone to have 2 plus 6 electrons, 8 electrons. Third energy level, it has got 2 electrons, 6 electrons, 10 electrons, giving us 18 electrons. Fourth energy level, 2 electrons plus 6 electrons plus 10 electrons plus 14 electrons. You get to add that to find the total electrons that the fourth energy level is able to have. Okay, so using this same knowledge, you need to know that an electron is represented by, okay, an electron is represented, one, by first the principal quantum number, and then you write its angular momentum quantum number. Okay, and then now what is going to be written? Okay, principal quantum number. Actually, don't write the angular momentum. So it's principal quantum number, that is the one which is going to be in front. Yeah, you write the angular momentum quantum number, and then on top we are going to have the spin, the electron spin, ms. So this is how you get to write electrons. The magnetic quantum number just represents the number of orbitals, just how many orbitals. Okay, for example, we're going to write an electron as a 2 s1. What does this mean? It means it is in the second energy level, having an angular momentum quantum number s, meaning that L is equal to what? 1. Okay, and this is electron number 1. Now you need to know that for the s orbital, it can only have 2 electrons, so you can't write 2s3. This is wrong. Why? Because the s orbital can only have 2 electrons, so it can either be 1 or 2. Okay, so this same knowledge here, now you should understand how to get to few electrons in an orbital. Firstly, let's start with the general, this one. If I say 2p3, okay, what are the 4 quantum numbers of this electron which is here? So the 4 quantum numbers, first, this means that n is equal to 1. L, whenever you see p, what does it mean? L is equal to what? What will be equal to, what will be L if we have got a p there? So what will be L? I don't know if it is forgetting or what. Okay, so I'm just from saying when L is equal to 0, this is S. When L is equal to 1, this is a P. This means that this is going to be, the angular momentum quantum number is going to be a 1. Alright. Now for a p orbital, remember we said there are 3 suborbitals. How? Because L is equal to 1, meaning that ML is going to be what? Negative 1, 0, and positive 1. So these are actually orbitals. Okay, these are the orbitals. You are going to have this orbital, and this orbital. Now for the, since these are all coming from the p, we'll write them together. Okay, we are going to connect them like this. So meaning that the angular momentum quantum number, well, I can't describe it now. Now we have got 3 electrons here. Whenever you are feeding electrons, you first put 1 electron in each orbital like this, and they should all have the same spin. Like they should all point in the same direction. So one have 3 electrons. So there is the electron that we want, the last electron. That is the one we're referring to, the third electron. Okay, so that means that ML, that is the angular momentum quantum number, the third electron is in positive 1. And then the electron spin, ms, you can see it is pointed up, that is going to be positive half. So these are the four quantum numbers for this electron, which is the 2p3 electron. We can describe another one. That means, let's say we've been given the 3 d, let me say 3p5 electron. The first quantum number can describe is the principal quantum number n is equal to 3. That's the number in front. Okay, the next quantum number can describe is L. If you just see p, that means L is equal to 1, right? And then the next we can describe is ml. Now since we have got L being equal to 1, that means ml is what? Negative 1, 0, and positive 1. So what we are going to have is something like this. Okay, let me actually put, okay, it's fine like this. Now we can fill in these electrons. Can I put a 4 here? Or it is okay like that? Okay, that means that when you are filling, remember we are talking about the fifth electron, so we need first to fill these electrons. Starting with one positive going up, electron spin up, the next one electron spin up, the next one electron spin up. We have used the 3 electrons, meaning we are remaining with 2 electrons. So we start now changing electron down, electron down. So this is the fifth electron we are referring to. We can see that ml, it is in what? In 0. That is the angular momentum, magnetic quantum number. And then we're going to have also ms, that is the electron spin. What is the spin of this electron? It is pointed down, that is a negative half. So these are the 4 quantum numbers for the 3p5 electron. Do you have any question? No, it's not always. I'm using the p, so it's not always. Let me use another thing. So let's say we have got 4d7. Okay, this electron, the 4d7 electron. Firstly, n here is going to be 4, this number in front. And then L. Whenever you see D, this should tell you that L is equal to 2. Okay, because we said when L is equal to 0 is S. L is equal to 1 P. L is equal to 2 D. L is equal to 3 F. L is equal to 4 G. So since we are having a D, meaning that L is equal to 2, right? And then we can now determine the magnetic quantum number. So since L is equal to 2, that means that ML is going to be from negative 2 to positive 2, negative 2, negative 1, 0, positive 1, and positive 2, like that. Can now put the orbitals. The d orbital, we should know that it has got 5 suborbitals. Okay, just telling from the ml, you can see 5 numbers there. Now we're talking of the 4d7 electrons. So we're going to start filling the electrons, starting with up 1, 2, 3, 4, 5. We are remaining with 2, 6, 7. Okay, this is the electron we are referring to. That means that ml is going to be negative 1, and then ms, that is a spin, it is pointed down, that will be negative half. So these are the 4 quantum numbers of the 4d7 electron. Are we alright? Do you have any questions? Okay.